session, Generative AI-driven sensitive data protection. This session is a level 300, and in this session, you'll learn more about how to use generative AI to protect your sensitive data. Before we welcome them onto the stage, if you haven't done already, could you please download the AWS Summit app via the QR codes on the screen. Please join me in welcoming onto the stage Zohreh, our Security Solutions Architect for AWS, followed by Pratima, our FSI Senior Solutions Architect.
Thank you very much. Thank you. Hi, everyone. I would like to start by acknowledging the traditional owners of the land on which we meet today. I would also like to pay my respects to elders past and present. Welcome to Gen AI-driven sensitive data protection talk. My name is Zohreh Norouzi, and I'm a security solutions architect at AWS. Today, I'm joined by Pratima Singh, our senior FSI solutions architect, and together we are going to show how to overcome challenges about data protection, a question that customers ask us most of the time. Data is one of the most valuable assets within your organization. It helps innovation, drives decision, and often it represents the core of your business. And with great values comes great responsibility. So it's important to protect your sensitive data. And today we are going to explore the solution on how to do that with AWS's solution, and we are going to show you something exciting using generative AI to accelerate and automate your response to potential data risks. Here are some statistics that show the importance of data protection. According to the report of the Office of Australian Information Commissioner, the OIAC, covering July to December 2024, the most affected sectors reported data breaches are Australian government, are healthcare, followed by Australian government and financial organization. These organizations are mostly holding sensitive data, and they are good or valuable target for malicious cyber activities. And as you see, based on when we look at the type of the data being included in these data breaches, we see contact information, identity information, financial records, health information, and etc. So it's important to protect the sensitive data. These breaches and these numbers goes beyond the number. It affects real people. And today we are going to share how to do these protection. But before that, let's align on something. What is sensitive data? And by that, I mean sensitive personal data. So we have personal information. And according to the OIAC, personal information are anything that can identify an individual. It can be name, address, date of birth, and etc. It's a broad category. And within that broader category, it's sensitive information, and where things get more serious. And they have higher level of data protection under the law as well. It can include the health information, genetic records, and financial records as well. When it comes to data protection, most of the organizations, like financial organization, healthcare organization, and other organizations, face with a couple of challenges. And I'm going to mention 3 of these main challenges. The first challenge is data growth and distribution. Organizations are creating more data than ever before. And they're not storing these data only in one place. It's distributed across different systems, environments, and resources. The second challenge is the ongoing and the evolving regulation. The privacy regulation is evolving, and they are adding their requirements. They are changing the definition of what counts as sensitive data, and they're requiring more. So it's getting complex for some organizations to stay up to date and stay compliant. And the third challenge is about resource investment, the ongoing cost and complexity of data protection. Usually teams want to monitor their data. They want to have a classification strategy in place and update that, and also have a protection system in place and update that. And finally, they have to train their team to stay up to date with all of these requirements. Today, we are going to talk about an imaginary scenario. It could be a healthcare or a financial environment. But For this talk, we are thinking about a healthcare environment where they're dealing with sensitive information most of the time. So they have personal information, personally identifiable information, PII, protected health information, PHI, and they have distributed systems. For example, they have a production system where they're dealing with live patient records. They have a development and research team who are working on new diseases, and they also have a test environment. And these type of data and the amount of criticality of the data are different for them. So they want to have a central place to manage their data protection and also be able to minimize the cost by minimizing the human effort to work on those findings and reduce the unnecessary escalation as well. However, they want to stay ahead of everything. They want to reply to security incident or potential security risk as soon as possible. How we are going to do that? As I said, when it comes to health information and sensitive health information, most organizations must follow specific regulations requirements, like under the Privacy Act and the Australian privacy principles. So these healthcare, the imaginary healthcare, they used AWS Cloud to build their solution in the first place because it's the most secure cloud. Now they're going to use AWS's controls and features to build their data protection policy. And with that, they're going to use generative AI to speed up and accelerate their response to potential risk. Gen AI gives you that capability, but it's important to build that responsibly and securely, which AWS give you the services and features required to do that. Amazon Macie is the data protection service. And this is going to be the first and the foundation service for our solution for data protection. It continuously scan your S3 buckets and looking for sensitive data. And it can do that in two ways: continuous automated scanning or through specific discovery jobs that you define. Macie also actually doing have different custom identifiers to do that. It is a managed identifier that Amazon Macie defined that for you, which is very generic. I'm going to talk about that in a minute. And then custom identifier. Macie continuously scanning for the information and have an inventory of your S3 buckets. And have that information such as what is buckets in buckets general configuration, tags, encryptions, setting, and etc. It also saves what is buckets permission at account level and at bucket level, and some other information at the object level. What is the counts of those objects? So imagine if someone going to change the bucket permission, Macie is going to pick that up from the CloudTrail logs and update that inventory. I mentioned that how Macie is going to discover the sensitive data through managed identifier or custom identifiers. Managed identifiers, you can think of them as a built-in patterns that Macie use to find specific data. These are a broader category that can be applicable for most of the organizations and countries. As you can see, it can detect, for example, for the password, AWS secret access keys, which is not a personal data, but it's a sensitive data, and then other sensitive information such as credit card number and health information. As you see, we have health information related to US only. But what if you want to create some identifiers that is specific to your organization, like the employee's ID, or specific to Australia, like Medicare numbers? Here is when you can use custom identifiers. It's very easy. You are going to tell and teach Macie how to use different patterns to find a specific type of data, and through these custom identifiers. I'm going to show you a sample. Here I created different custom identifiers in Macie's console, which is, for example, the Medicare number, Centerlink reference number. And for my specific scenario that I'm going to talk today, it is International Classification of Diseases code as well. As I mentioned, the healthcare scenario have distributed environment. They have production system, they have development and research system, and they also have development system, the test system, sorry. So they need a central place to manage all of these environments, which may see an organization give you that capabilities. You need two main components. First, AWS tooling account, which is going to serve as the Macy's administrator. I recommend that you only allow your security team to interact with the Macy's administrator because they can actually enable Macy in different member accounts. They can set the automated discovery or set discovery jobs for the member accounts as well. And then we have member accounts in each of these production systems. Now, we actually respond to one of the challenges, how to centrally manage Macy. Let's see how the flow of data protection looks like at this stage. We've established the data strategy. For example, anything related to production account have a high criticality. If there is a bucket with sensitive data like PHI and the bucket policy is weak, it's going to be super urgent. Or if there's anything related to, for example, development and test account, that's not that urgent. It can wait until tomorrow. Then we define our identifiers. We use managed identifiers to say, for example, the patient data like name and address and phone contact, and also the custom identifiers to define what is the international classification of diseases. And Macy is going to scan these three buckets in our environment and generate some findings. Now the SecOps team are going to look at the finding, bring their manual readable playbook to add the business context to that, and then decide if it's an urgent finding that I need to take action and, for example, escalate that, or it can wait until tomorrow. But there is a challenge here. Imagine that there are hundreds and thousands of findings. How the SecOps team can manage their time to reply to all of those findings and answer to all of those security, potential security risks straight away. So they want to, as I mentioned, they want to minimize the human effort, which leads to minimizing the cost and also minimize the unnecessary escalation. How we are going to do that? With the help of generative AI, a solution that Pratima is going to walk us through.
Thanks, Z. So Z has talked about, or Zohreh has talked about, the different challenges that you have with security operations. Now, security operations is largely a very human-intensive function. Security teams build their playbooks or response strategy based on business strategy. Now, this strategy is generally written in human-readable language, so primarily English if we're talking about Australia. Now, think about an environment where the security operations team has to now port that strategy into implementation playbooks, convert those playbooks into codes and queries that they run on the data that they have and the number of findings that they have. And then from that, operate on that information effectively to determine whether this particular finding should be addressed, say, 3 a.m. in the night, or we can park it for tomorrow because this is an isolated account where we are seeing this and it's an outcome of a testing. On top of that, security operations teams or any operations teams would have to maintain a standard operating environment where they're able to execute said playbooks and said code, which is a fair bit of overhead that they have to maintain today. Now, customers have a range of choice with generative AI tooling on AWS. And where generative AI tooling becomes useful in this case is that you can use this tooling or you can build models or prompts to be able to augment the human interpretation function in a standardized way without having to maintain large SOEs or without having to maintain standard operating environments in your security operations function. And the human role now elevates to more of an assistance or an assertion of the data that has been pulled out and the interpretation that the AI model has run. Now, for the purpose of the demo that I'm going to show you in the next few slides, I've used Amazon Bedrock and I've used Amazon SageMaker. Now, Bedrock gives me the capability to choose from a range of LLMs. And to be honest, I haven't had the need to train any LLM to give me the right responses or the responses that I'm looking for. And I'm using SageMaker towards the later half of this presentation, I'll show you, for running Jupyter Notebook. So that's the easiest way I can maintain like a standard operating environment, and I can work with least privileges. Now let's go back to the data flow that Z had shared with us. We've got custom identifiers and managed identifiers. We've got a data strategy in place. We have a Macy finding. What happens when we inject that generative AI application in it? The human overhead of, the cognitive overhead of interpreting the business strategy, converting it into additional code, and on top of that, getting business contextual information from the findings that have come through Macy are all aspects that you can offload to a Gen AI application and then use it to inform your response and reduce time to respond as well. So Macy detects an S3 bucket, has multiple findings with multiple identifiers. Say some of them are custom identifiers, some of them are managed identifiers. Now, according to your data strategy, there might be different ways to operate when you have a mix of both kinds of identifiers, or some might be mission critical identifiers, some might not be as such, and that's all human interpretation, right? You create an event bridge rule to trigger a workflow, which is based off of a generative AI application. Now, I've given my Gen AI application I would say two parameters. One is my playbook, and one is my Macy finding. Both of these are, the playbook is plain English, whatever I write, and the Macy finding is coming through the event bridge rule. Now I need some sort of contextual information coming through. I can integrate my generative AI application into my CMDB or configuration database, wherever I have information about which account is production grade account, which account is, say, PCI in case of financial services, which accounts are less sensitive, because they're all, playground accounts. We're gonna trim them out in a bit, and then I have another application that basically goes back to Macy and asks for policy findings, because I could have sensitive data in an S3 bucket, and that S3 bucket had controls where it was open to the public, which is the most urgent use case that I need to resolve today. So Macy does collect policy findings that you can have the Gen AI application fetch from Macy as well. And what do you do after that? The application is then able to interpret that information and tell you, hey, you know what? The urgency of doing this is high or low based on these different criteria that you've defined in your playbook. And then you can operate on it. You could have a Lambda function, or you could have step functions that would go in and do the certain task that you would be doing as a human. Now, a lot of the time, security operations teams do have scripts that go ahead and do those functions for them. But with generative AI, it's a very good candidate to transform them into tools for your generative AI application to use. Now, I don't have a video because it's a large playbook that I wrote with the help of my colleagues, but I'm going to take you through the different pieces. Now, on the screen, you see my playbook. My playbook is plain English. It has 3 steps. The first step is determine which account is this. Is it production account or is it a non-production account? If it is a production account, it is high urgency. The second step is identify the kind of identifiers you see through this Macy finding. And these identifiers are either custom identifiers or they are managed identifiers, and I'm telling the model that if you find both of them, it is highly urgent. If you find one out of them, then this is the different kind of tag that we're going to apply. And the third one is you need to tell me like what to do with it, right? Is there any other policy-based finding? Am I supposed to be worried about this bucket being public at all or not? So now I have a very real Macy finding. This is a very short snippet of a Macy finding. It is generally really large. And what you see is information on an S3 bucket. In itself, Macy's finding will give you a lot of information. Which S3 bucket is this? Which account is this? What kind of data have I found? Is it managed identifiers or custom identifiers that you've written? And ARNs of the different places that it's seeing. So that's a lot of information for humans to read through and then go into separate pieces of data and find out more, like query more around it. Now I've got all the pieces in place. I've got my 2 parameters in place. This is where everything comes together. Because I'm using Bedrock and AWS services support API integrations, I'm using basic Boto API to connect with Bedrock. I'm using Anthropic's Claude model, 3.7, Sonnet v1. And I'm going to use an inference profile because that model requires it. But because of Bedrock's, Bedrock already gives me an inference profile. So I literally have to create no infrastructure when I'm trying to do this. I just incorporate that particular LLM, and I follow the process of using that LLM through Bedrock. I haven't had to train the model either. Now, if I look at what's happening next, is my 3 steps. They now become my tools in the implementation of this application. So my first tool is, how can I get information about what account is it? Number 2, what kind of tag should I apply, depending on what kind of identifiers you have found? And if you look at it further, it's primarily prompts. There is no case statements. There are no if-else statements. There is no code that I have written here. I would like the LLM to do that interpretation for me, because that's what's being enhanced from my security operations function. Now, moment of truth. This is where everything comes together. I've defined all of my inputs. I've defined all of my tools. And I'm giving this playbook, or I'm giving this Jupyter notebook a Macy finding to operate on. So I see 3 different aspects here. I see step 1. It's telling me details on what kind of account it is. I don't know if you can see the font, but I can narrate it for you. Number 1, what kind of account it is. It's going to tell you it's probably a non-production account if it isn't. If it's a production account, it'll tell you it is. Then it says, based on the kind of identifiers I found. Now remember, I had 3 identifiers in the finding that I'd showed, 2 managed and 1 medical data coming from a custom identifier. And it's telling me, based on that, the tag you'll apply is medical data. And then finally, it's also telling me that there are no policy findings. But in the end, looking at the kind of information that I have mentioned in one of the steps, that was step 2, it does tell me that this is a high urgency finding that you must address today, because you've got medical information. Now, if we port this entire thing from a medical scenario to, say, a financial services scenario, your identifiers would look like, hey, there's BSB or account numbers here. Your custom identifiers could be more than just the Centrelink numbers or the ICD codes. Now, you could build these based on regular expressions, as you saw. So now the security operations function has uplifted itself to assert the LLM's output, not having to spend multiple hours on fishing through data to make the assertion whether I should be solving this or not, or what do I have to do with it. And now I can use all of this information as well in my paging system. So I can provide basic English responses to my responders so that when they wake up at 3 a.m. at night, they're not having to revive themselves because they now have to look at chunks and chunks of data. They have exactly what to go in with. Now, can we augment this further with Gen AI? Of course we can. There is no conversation in this day and age complete without talking about generative AI. And as we talk about generative AI, new things come into the picture. So when we started building this session, MCP was nowhere. And then we realized a few weeks ago, now there's MCP, which is a brand new thing. But what it's helping you is this technology is now evolving to help you build more standardized interactions with the different tools that I had created. I could extract them into agents, build them up as MCP servers, or even use connectors into, say, your Salesforce environments or your CMDB environments that have contextual information about your business, about the AWS accounts, or information about the different kind of tags you want to apply, and pull that back through an API construct and feed it back to the LLM. So now the LLM has standardized mechanisms of operating on data. So let's go back to the challenges that Z had talked about. The first challenge was interpretation of playbooks, right? Because the data strategy is in English, we've had, or any language that the LLMs might support, we have the LLMs doing the interpretation for us. So now as a security operations function, my team or me, I don't have to do that interpretation myself and keep up to date with how the business strategy is changing and how I need to update my scripts. I'm not having to write code to do the interpretation myself. Maybe you do have code, say specialized queries. You could extract them into tools, and the value add you get with generative AI is instead of giving you a bunch of rows and columns with the information, it's able to interpret that for you and tell you what it thinks is happening in your environment. And then finally, you no longer have to maintain a standardized operating environment because you've offloaded all of that to that LLM and to that serverless workflow that I just showed. So if you were to now go back and use this in your environments, the easiest way to get started is to start using Amazon Macy. Start looking at what kind of findings it's generating. identify the custom identifiers that you might need and start building them with regular expressions. See where generative AI can augment your security operations functions. So yes, we do talk about a lot of productivity uplift with generative AI, but this is where we see it coming into the security operations function. And have a look at the blog that talks about how you can use Bedrock with Amazon Security Lake to be able to run your queries and to be able to interpret what's happening in your environment. And that's all we had for today. Thank you so much for being here. And if you did like our session, please give us your feedback. We would love to hear from you. And we would love to improve ourselves for the next ones. Thank you.
Perfect. Thank you, Pratima and Zohreh, for your informative session on the use of generative AI and its uses in security. In a moment, we'll be putting the QR codes on the screen, and please do take the time to provide our presenters feedback via the AWS Summit app. Lastly, if you could leave all the headsets on the back of each seat before leaving, that would be great. Thanks, guys.